Hello everyone, this is Dhanalakshmi, Assistant Professor of Triple Department from R Engineering College. In this session, I would like to discuss about step-up chopper. Step-up chopper, where the subject bioelectronics in the unit 3, it's all about DC-DC chopper. So in the previous video, we were discussing about step-down chopper. When we take the types of chopper, the very fundamental types are step-up chopper and step-down chopper. So in the last video, we discussed about step-down chopper, and for this session, we'll take step-up chopper. We'll discuss step-up chopper. Okay. Step up chopper, as the name itself tells us that step up chopper, so it is going to step up the voltage or it is going to boost the voltage. Right? If the output voltage is always greater than the input voltage, then we can call that chopper as a step up chopper, where the output voltage is stepped up or it is boosted. As we know already, that chopper is a one which is equivalent to a transformer, AC transformer. Like the transformer we have in AC, what the transformer will be doing, it will be either stepping up the voltage or stepping down the voltage. Same way, here the DC-DC chopper will be stepping up the voltage or stepping down the voltage. So if it is going to step up, or if the output voltage is greater than the input voltage, then we call that as a step up chopper. If the output voltage is less than the input voltage, then we call that as a step down chopper. Right? And all, as we know that chopper is the one which is going to convert the fixed DC input to a variable DC output. So this is the configuration of a step-up chopper. So here we can see that there is a source and we have an inductor connected at the source side, which is not the filter. It is the inductor connected at the source side. And here we have the switch connected parallel to that. Here we have a source, an inductor, and parallel to this source and inductor, we have a switch, a chopper switch. This switch again, it can be a BJT or IGBT or MOSFET. And here we have a diode connected in this direction, and we have a filter capacitor and load. So this is the configuration of a step-up chopper. So we'll see how this is working. So when we, as the role of a switch, or as the role of a, as we know, the chopper is a switch. The role of a switch is to on and off. So it is just to connect or just to make the circuit or break the circuit. So here we can see that. So when the chopper is switched on, right? When this is on mode, as we can see that when the chopper is switched on, the energy, you can see that the source is now exactly connected parallel to the inductor, not to the load, right? So here you can see that when the chopper is closed, or when the chopper is switched on, you can see that now this becomes a short circuit path, and now you can see that the source current is entirely flowing through this inductor and it goes back to the supply. So no way it is connected to the load. So during this period, the inductor will store the energy. Right, so the source is now exactly connected in parallel to the inductor. Therefore, the energy is stored in the inductor. So during this period, there is no output voltage available, because as you can see that when the chopper is switched on, which means that this path is a short circuit path. As you know that in the short circuit path, so as we know that in the short circuit path, the voltage is 0. So therefore, the load voltage will also be 0. So therefore, here we can see that during on period, during the on period, the voltage is 0. Why? Because the chopper switch is turned on. So when this is turned on or when it closes, what will happen? The voltage is 0 across the chopper, and since the load and chopper are parallel, so we can see that the load voltage will also be 0. So during on period, output voltage is 0. There is no output voltage available during the on period of the switch. So, and during the on period, only the inductor will be storing energy. And you'll see what happens when the chopper is turned off, right? When the chopper is turned off, now you can see that the source voltage along with the inductor already in the previous cycle, it has stored energy. Right? So now the inductor has energy, and this source along with this inductor will be feeding to the load now. Right? So during off mode, here you can see that during turn on, the output voltage is 0. We have only the source current, which is charging the inductor, right? Whereas during turn off, you can see that now the inductor will be discharging, because it is releasing, it is delivering the energy to the load along with the source. So along with the source, then this inductor is delivering the energy to the load. So therefore, during off time, I will be getting my output voltage and the current. Is that clear? So during on period, the output voltage is 0. And during off period, the output voltage will be the source voltage plus the inductor voltage. Where in the previous cycle, the inductor stores energy. So here we can see that. So when the chopper is on, the inductor will now exactly connected parallel to the source, and no load is not connected. So the output voltage will be 0. So here you can see the current will be flowing, the source current will be flowing from the positive of the supply, goes to the inductor and back to the negative of the supply. No current flows in the load during the chopper on period. And when during off period, the source voltage along with the inductor voltage will now be delivered to the load. Here you can see that the source voltage along with the source voltage along with inductor voltage is now delivered to the load. So that's why you can see that V naught output voltage is Vs plus the inductor voltage. That's why it is the voltage is stepped up. So you can see that the voltage is stepped up. Why? Because then now the voltage is given from the source along with the inductor. So therefore, the output voltage is V naught is equals to source voltage plus the inductor voltage. So that's why we can say that as a boost voltage. And this is the derivative part we have. We can getting that is finding the average voltage across the inductor during on period and off period and equating those two. Finally, we are getting our output voltage V naught as 1 by 1 minus alpha into Vs. Yeah. So when we equate the average voltage across the inductor during on time, during on period and off period, and equating those two, we can see that the output voltage V naught is equals to Vs times 1 by 1 minus alpha. This is the output voltage equation of a step-up chopper. So therefore, you can see that Vs into 1 by 1 minus alpha. So when we choose some value of alpha, you can see that always the output voltage will be greater than the input voltage. So in short, we can summarize that the average voltage of the load will be always stepped up by varying the alpha. So whenever you vary the alpha, if I take my alpha to be 0.5, 1 by 1 minus 0.5 will be again 1 by 0.5. That is 1 by 0.5 is nothing but 2 times of the input voltage. So therefore, thus we can conclude that this step-up chopper will be having always the output voltage greater than the input voltage. When the switch is off, the output voltage is Vs, and the switch is off, when the switch is off, the output voltage is Vs plus Vn, that is voltage across the inductor. And when the switch is on, there's no voltage at all, right? So altogether, when you average it, you can see that the output voltage is always greater than the input voltage. So that's why we name it as step-up chopper. So step-up chopper, where it will always boost up the voltage. Thank you.